Right. I'll share a little bit about what you can do with within molecule then. So I've put it into three basic categories: the core things that you can do, which is like basically normal stuff, and then some extra stuff I've done, which is things I've added on top of Datomic, which makes it something easier in Scala, which is like some extra stuff. And then there's the whole time aspect, which is extremely cool in Datomic. So you have seen that entities are like groups of facts with a common entity. And you can have any facts typed together. So you can really tell which attributes can we expect from this entity, because it can be put together of any attribute value, right? So therefore, Datomic has this entity API, which is a runtime call you can make. So you can see, you can take an ID, which is just a number. So with the molecule, I have made this touch command, which is also a method in Datomic. And then you get a map of attribute names and their values. So you can like traverse an entity value and see which attributes it has. But it's you don't know what you're going to get. So it's like you will only know at the runtime what you will have. So I made like a semi thing. So if you wanted to know, for instance, that it might have a category, a person might have a category. So I want to see if there is a category for that person. Then I know it's a type of string, so I can say an optional string. Take the ID number as a string, and look for that for the value of this attribute. And then I might get might or not get that value. Now we come into your question about the namespace, because when we write person name, namespace attribute, it gets translated to this, which is what Datomic wants in the query. So when we have two attributes, it's reusing the namespace name. So person is reused here and there, and the first attribute goes there, and the second attribute goes there. So when we get multiple attributes back, I've made it as tuplets that you get back. And those are typed, so you know that you get a list of tuples of type string and integer, and you can have any kind of. So of course you will maybe say that okay, there's a limit of 22 values in a tuple, but you can also have like tuples that are tuples of tuples. So basically you can have like 22 by 22 attribute, which is very small. You need so many, but I'll show you that in a moment.
Question.
Yeah.
If you have the site category in the first example, how would you write that in the DSL?
I'll come to that in a second, because it's not obvious how you get there. And you spotted it right there. If you look at this is an interesting query, because I put likes together also. So I only get Fred and Ben. Why don't I get Lisa? Can you see that? When I ask for persons' names, ages, and likes.
It doesn't have any likes.
Exactly. There's no attribute stated for the entity Lisa that she likes something. So therefore, what I'm doing is that when I write the attributes, they're mandatory. So when I make a query, I'm presuming that the values have to be there. I'll only return those that are there. So the fact exists, and there's the value is returned. But sometimes we want to also know that there is a value, but we don't need to return it. We just want to know that it is for sure there. So we still get Fred and Ben, but we don't get the likes value. So that's why I call it tacit value. That it's silent. It exists, but we don't get it back in our result. We can also have an optional value. So that's how we get Lisa also. So in her case, we just get a none, because there's no likes. And for the other tools, we get an optional value, some value. And we can start narrowing down the query result, and then we come into a little bit the question of narrowing down the result set. So we can apply a value to the likes attribute. So we only get those who like pizza. So we only get Fred and Ben in this case. And this is a typical case where we don't need to return pizza because we just told the query that we want all those who likes pizza. So then we don't need to get that information back that they all know pizza, right? You see, pizza is there twice. So if you had 100 persons, we don't need that value. So if I put this underscore, it's like a tacit value. I don't need to get it returned, but I know it's there, and I know it's a pizza that they like. We'll also have like full text search. So if you define that in the schema definition, that it has to be a full text search, then you have a Lucene indexing of the whole text of those facts. So you get super fast search capabilities when you do this contains Ben. But it's only full words. So if you write B, you don't get that. So you will have to make that more manually, like with the regex or something. You can also do negation. So all persons that are not 38, you can write it in two different ways. And you could say like, I want all persons that have no likes fact asserted or retracted at some point. So then you get the only sign. And you can have bigger than, smaller than, you can compare and so on. Average, median, variance, standard deviation, discounts. And you can even take out random entities from the whole set. Or percent.
Are those implemented in Datomic?
Yeah.
Okay.
Yeah. So they're core functions of Datomic. So what Molecular does is simply just write a Datomic query that has those functions. So it's not possible. And then you have all logic that you can put in like ages that are 5, 6, or 7 years old. So Fred is excluded, and you can write it in 3 different ways. So one cool thing about Molecular is also that you see I write the sequence here, but that sequence might be like a list of 1,000 things that you have in a variable. So the variable could also be here. It doesn't have to be like manual data that you put in. It could be a variable from data that you have somewhere else. That was a little bit tricky to implement with the macros, but it's possible. I just went through here. So now we come to the relationships. So we define this one address, then you get a reference from one to the other. So that the name you give it doesn't have to be address. You can call it whatever you want. Right? So you from home. So when you write this, the word home is what is put in here. So person home, the home references down to the address. It doesn't have to be the same name. I mean, it could be any name. It could be X, Y, Z. There are attribute names. Doesn't matter. What matters are the entities. So the value of this home attribute is 102. That's a long number. Since that number is the same as here, then they're connected. That's a relationship. So there's no more magic than that. You see, that's pretty simple. It's not that there's a connection where I have to have like a foreign key to some magic table somewhere else. So we can write it that way also. So when we ask for a person name with a home street, we get Fred, and then we get this implicit connection that from that entity to that entity, because they share the same, the value is the same as the entity, and then we can continue with the values for those attributes.
What's the .1? The query at the top, street.city.1.
Yeah, one. That's instead of get, we get a list.
Mm-hmm.
Then I just made a method called one, when you know that you're only gonna get one result, which is more typical when you get like a count when you ask for how many persons are there, count persons, then you know it's one result. Then instead of writing get and then head of the list, it's just a convenience method. I could call it head also. But instead of writing get and then the head of the list, so it's just convenience. So I could have two different references to the same namespace, right? You could have a home address and a work address. So how would you get there? And then now we come to your, well, not yet, it's another, because you have, I've created a back reference. So you want to go and catch some attributes from some other namespace. But then you want to go back to the first namespace and then go again so you can write the other attributes. Do you get it? So you both want the street and the city from the home. You both want these two and those two. So first you go from the home here. You go down to this ID, and then you catch street and city from the home address. And then you go back to person, and then that's that one. That's the back reference here. It's just a convenience way of type-wise in Scala to get back, so you can take an address from another namespace. So now I think it starts to resemble a molecule where you have like arms of different data bits, and you can have several. You can have as many as you want to. Then, if you look at the kind of manager relationships, you can see it's the same here. We have subcomponents with many lineups here. So now we have, when we ask for an order ID, we get this order ID, and then we have some items, which are those two items here. If we write it like this, then the order ID is collected every time, because that's the thing that they have in common, right? Because it starts with that. So it's not really convenient when you have like hierarchical data, because you don't want to have that information so many times, because if you have 3 levels, you have a lot of information that comes again and again and again. So therefore I created what I call nested facts with this star sign. So I get a tuple with the order ID, that's this one, and then I make a reference to multiple line items that go in a list. So the second argument is a list of the tuples. You get that? And you can even nest that up to 10 levels deep. So it's just a way of organizing this information like this. Because you might have, like, if you have several layers, you want to have lists with a list inside with the list inside. So that's just a convenience thing that one could do. And with the entity IP we saw before, you can also traverse recursively down into a nested structure. But that you don't have the type safety when you do that. So you want to do it by nested queries instead. Now we come to your question. How do you get to this side? Because this falls a little bit out. It has nothing to do with person, so it's somewhere totally unrelated. There's no relationship from person to site category, right? So we could create one. We could say H and then go to the site, create a relationship to site, so we can write category. That could be one way to do it. But I think that's problematic because site doesn't really have anything to do with person, right? It's not intrinsic. It's not an intrinsic value of a person. So you can imagine that you start polluting your domain model if you start to write a lot of different things that doesn't have anything to do with person, just out of technical convenience to be able to write that. So I thought there has to be some kind of mechanism so you don't have to copy that information. So you have to have the freedom to write this instead. So you have like more like an association. So it still shares the same entity ID, but you can jump to whatever whatever namespace you want to, and then just continue from there. So what you get is that you have the two namespaces that are independent, intrinsic both of them. They're only about them, what they're defined to be about. So it's still the entity IDs that ties things together, and you can call the attributes anything, right? It doesn't matter. It's the entity that ties them together. So what you get is a tuple for the first. I call it the submolecules. You have two submolecules that together you can compose molecules out of submolecules, right? So you get a tuple for the first one, and here, since it's only one value, it's just one value here. But you could have two values also, so you get a tuple there. If you both got category and status from side, right? And you could even have more. So you can continue like that. So that makes domain modeling extremely flexible, I think, because you don't have to pollute your namespaces with things that, for instance, if you have tags, you might have tags for a lot of things, right, in your domain. Tags for a company, tags for this or that. So all these, what may be called cross-cutting concerns, you don't have to put them in all the places to be able to write queries that connects them. You can just have them freely associated with each other. So that was queries. Do you have any questions for the query part before I start with the...
Is there any sorting or grouping? Or
No.
No.
You do that in Scala. I think that's also because that's also touched on the because you have like limits in SQL, for instance. You don't have that in Datomic, and I don't know really how they do with huge data sets.
Do you think that you can represent most useful atomic queries in this DSL?
Yeah, but because I translated all the examples they have.
By composing it, you can kind of get any query.
Yeah. There's only they do some recursive queries that I haven't had use for them yet. But it should be possible to add that to the DSL also, to do recursive stuff. So yeah, because I thought this is so simple, it can't really implement. But I thought I'll give it a try, and I was surprised that actually it can implement everything. So I'm pretty happy with that. So if you look at the creation and updates and deletes, this is how you save stuff in the molecule. So you simply add the save method by the end of the molecule, and then you save the data. I think that's pretty self-explaining. And you might even have optional values, because you might have data from somewhere, and sometimes there's a value for likes and sometimes not. So you might have some value or none value. So this is the data that we saw before that we could have saved like this, because Lisa didn't have any likes, right? So we give it a non-value.
So, but you still have to know that this value might not be.
Yeah, but this is just this is creating 3 tags for Fred, right? His name, his age, and pizza likes. But for Lisa, it only asserts 2 facts. So it's not that it's saying that Lisa doesn't know anything. It's just not asserting that fact. So it's
Yeah, but you still have to make the $sign up in the first row.
Yeah, you would have to know that. But
you still have to know it in advance.
Yeah,
that this
but you can make
optional.
them. You can make them all $sign.
Yeah.
And then make them all optional. But that depends on your data set. Because normally, if you say something, there would be something that you know there's a value or some ID number or whatever, or that their last name is always there. So you could reuse insert molecules. You can make an insert person molecule. So you define a person name, age, likes, and then insert. So you haven't given it the data yet. You can do that later. So here we give it the data straight away, right? So this molecule, when we apply this list of data, then it gets saved in the database, and then we can get an entity ID for what was saved. So we can insert Fred like this. We can insert Lisa like that. That's pretty cool because then you can model different kinds of inserts in a variable, and then just throw that in whenever you need an insert for this app, and it's all typed. And you can give it either one value or multiple value also. I think it's the same. Okay. Yeah. So just to say that the read we already saw the read because we're going through the CRUD, right? So all the read, different kinds of reads, we covered that before. So when we want to update the value of what thread likes, we simply give it the ID number. We start a namespace with the ID number, so we know that it's thread we're talking about. And then we take the likes and give it the value that, and then update that. So the new value is asserted, and then Datomic automatically retracts the old value, which was pizza. That was the two facts we saw before, right? So that's when we say that we assert a new value for a cardinality 1 attribute, then Datomic automatically retracts the old one. That's happening behind the scenes.
Could you update the age in the same plugin?
Yeah. So you could have as many as you like. So this is. There we have the fact, right? You can also apply an empty list, which is saying that we want to retract the value. So now he doesn't have any likes. So that's how we do that. And this is when you have cardinality many. So if you had an attribute which was hobbies, you can see the different stages of how you would manipulate cardinality many. So you would add the first value, and then you would update that, right? Or it could be part of an insert from the beginning. So you might have like those three values. So then you want to replace cars. So you can make this a pair of values. So you can say that cars should now be retracted, and then we want to assert trains. So we update that. So now cars is gone, and trains is there instead. Or we could remove golf. So all these remove, replace, add, update with the that's the method I created in Molecule just to do the same things that Datomic does. So we can remove golf analysis on this, or we can simply apply skiing stamps that overrides. It retracts the all old values. So it looks up what are the old values, retract those, and then asserts the new values. So that's a way just to replace the old values. Replacing, you know what I mean. You see, and then I can apply an empty list. So then we end up with no. So that basically means that we retract the two last ones. Does that answer your cardinality many? You have some question about how this semantics work.
Yes, some of my questions. I was still wondering about when you have relationships between. That's a different question.
Yeah, I think we'll come to that also. When we have an entity, we can retract an entity. You remember, an entity is just what collects a group of data, right? So if we took the thread ID and retracted that, then there would be no thread anymore, because the entity ID would be gone, right? It was retracted, so it's no longer present in the database. So all the 5 facts would have been retracted. Right? So it's a very easy way to you take an entity ID number and just write retract, boom, all the facts are gone for that. Well, not gone, they're still there, but they are retracted. Right? So the extras is that you can do, for instance, a match string, which is really convenient if you're working with multiple languages. So what I've done is I've done cardinality many string attribute, so I can have many strings in one attribute. and then I prefix it with different keys. So it's very simple. It's basically just a string with like a key and then an @ sign and then the value. And then I take that out when I give the value back to you in molecule.
Best composer.
Yeah. Yeah. So it's just a. So I don't know how you do if you have how you save data for multiple languages, because you might have the main language English, for instance, and then you might have property files that when you have this term, it's this in Swedish, it's this in French, and so on. But if you want to save it in the database, it's a mess, no matter how you do it.
There's a library called Rapture that supports multi-languages in a typed way.
Okay, I have to check that out. And then of course you can query by the key. So give me the person names in French. That's with CH. Or by a value. Give me composers that have a value like this. Or you can give it a regex. So you match all those that have this pattern. Or by key, the English ones that has this regex and stuff like that. So it's just different, and there are quite a lot more combinations. So I think for multi-language data, if you have data which is not only like standard terms, but also like text that needs to be in different languages, I think this could be a way to do it.
Okay. Can you? Is there no like complex types in Datomic?
You mean compose like of two types, for instance?
No, more like. Is there like a map type or JSON type? Or
No.
Is it, no, it's just...
But they have like, no, that's not really complex, but URI and UU, ID, but not composed data structures or data types.
Because you would think that this could be implemented like with like a JSON
Yeah.
data type,
Yeah,
where
yeah.
just the JSON as a string and then you would parse it.
Yeah, of course, this you could easily model as relationships also, right? You could have a key which would be like go to the English version. You could have a key that goes to and so on, because Datomic also has enumerations, so you could have like a fixed like the name of the languages, for instance, and stuff that you could use as keys and stuff. So I think it's very flexible to model as you like. So this is just a convenience thing I did. Then there's the second thing is they can do input molecules that have this question mark. So it's a molecule that expects some data at a later point at runtime. So you create this input molecule that you can reuse. So it's a person, you get the ID, but you don't. You ask for the name, but you don't need the name back. So you give it a John, and then you get the John ID, right? And you can get students. You can get a variable with the sequence of a lot of names, and you get all the IDs of what is found. So that's another way of modularizing your code. So you could have like a person finder molecule that you can reuse whenever you need to find. So you don't have to write all the attributes that you want to have. So it's just a convenience way. And you can have multiple. Well, I have up to 3, because you can even like do a logic like. So you want to find all Johns that are 42 years old and Jonases that are, or Jonases that are 38. So you can apply values and have expressions and all this. So that things flexible. And the last thing of the extras is like a way to make property graphs, which is where you need kind of bidirectional references. Because if you make references for something to somewhere else, then you can say that a person named Anne has a reference to friends, where the name is Ben, and we get, if we take a person named Anne, then we get the name of Ben. But if we go the other way, then we get an empty list, because the relationship goes one way, right? So what I do is, you can go backwards. You can say, instead of, if you want to find who We're the friends of Ben. You can say that, well, if you put Ben in the second position here, you can go backwards and see that the name, who has a friendship to Ben? And then we get out. But we want to be able to go in both directions. So I created this bidirectional references, so you have a mini bidirectional reference to a person. So it creates a fact one way and a fact the other way. That's something that molecule does. So whenever you do a query, then you get the more natural answer. Right? And since molecule
is that saved in the database from the beginning?
Yeah.
So when I enter the friend, it's also recorded.
Yes. Yeah. So it's both all the operations save and insert and everything. So normally you wouldn't do such a redundant stuff, and but since the molecule is like a closed ecosystem where I control the whole system, I can also ensure that they are created correctly. So that's how it's possible to do. That's the beauty also of having a closed ecosystem. So I can go from Arne to Ben to Joe, even like in three levels, right? And I could even add properties to it. So I could have a person that has many bidirectional edge, which is that one, that has some attributes. So you can make a property graph. So if you look at this as the edge of a property graph, then you could have properties. So you can see how well does Arne know Ben. It has a weight of 7, right? So you can have you can define as many properties you want here. So I think that's pretty cool. So that's just some examples of what you could implement different things. You see the possibilities are quite endless. Then you have some time. You have this transaction data where you have the time to. I said the time is recorded with the transaction, and you might wonder, like, what is this transaction? Is it some magic thing somewhere else? No, of course not. It's actually just an entity. So as is the reference, this transaction, instead of being a value here, a reference to another entity, it's now in this column for transaction, and it points to this entity here. And that has the value of the time. So the transaction history is data exactly as your domain data. So it follows the same as the schema. So you see, both schema, transactions, and the data in the database has the same format. It's quintuplets, all of it. There's no magic anywhere else. I think it's beautiful. So let's also, you can see. Yeah, I was just about to give you a quiz. What would be there? What would be the transaction value of these transactions? I should just show you. That would be also transaction 4. There's a reference to itself. So you could basically look at it as just entity in numbers also, right? So the transaction is nothing magic. It's just an entity number. We just call it transaction because we associate other semantics with it. So here you can see. So this column value here is a long number. You have a text which describes which attribute it is. You have some value. It can be different types. And the transaction is also just a number. So that number here is this number, right? And that number is also this number. And then they're asserted, which is like an operation. That's just a boolean in the database. It's just true, which is asserted, and false if it's retracted. So you have a long, and then this is a closure keyword, and various types, and a long and a boolean. And actually the closure keyword also is actually just a reference to a long number. It's just a convenience way of writing a long number. So that is the attribute name is also just saved as a number. So it's also an entity in the schema, describing the value, the name value of the attribute. So in the code we can write person likes, but in the database it's actually just an entity number. So the entity number goes here. So now we are as much, almost as close as we can get to what is saved in Datomic.
Yeah, so this is why the database is really its own index.
Yeah.
You don't need any extra indexes. No. This is an index.
This is an index, yeah.
Makes sense.
So that's also why it's really quick to look up stuff by the attribute name, because it's not a text string. It's a long number. So, for instance, the person likes might be 148. The entity, that entity, right? So it goes really fast to index it and look it up.
So could you have an attribute that, so Fred likes transaction number 4?
Yeah, you could do that.
Then create loops. What happens?
Yeah, of course you could. That's the recursive nature of it, because you can go from one to that will go then to back. So you could have like loops, or you could have like recursively endlessly, because it's just a reference to other places, right? But I think there are some mechanism to avoid like endless loops in the query results. I can't remember exactly.
What happens if you save the same data twice? Or you can actually but I save twice.
It's a good question, because then Datomic has a mechanism that it doesn't write the same data twice. So it simply ignores it.
But then doesn't update the transaction date?
No. And that's also, so if you reassert the same fact, then you actually lose out on that you are reasserting it, right? It could be of value that you repeat, that you say it again, that I like pizza, right? He has said it for a second time, right? It could be of value, but then you would need to model that in the database. Like
isn't that automatic when you use the update thing from your CRUD?
Well, if you update it with the same value as it currently has, then nothing happens. There's no new fact asserted, because it has Datomic checks that it has the same value.
Maybe something for your library then, to have some kind of exclamation mark or something, saying that really touch this one again.
Yeah, you could definitely
if you need it.
Yeah, you could definitely have that. But it's also interesting because when my SPT plugin translates your schema definition to all the boilerplate code, it also creates a file with all the code to create the schema. Right? So, and if you are doing a migration, then you could change one attribute name and just run all the same code on the database, because all the schema that is the same won't be changed. It's only the new fact. So that's a way to update your schema.
So a molecule knows how to create all the schemas in the Datomic database for you.
Yeah.
You don't have to do it anywhere else, or?
No, because you remember I wrote like a value, a name is a one string. So that gets translated to the boilerplate, so I can write person.name, but it also gets translated into a file where you have the data to create the schema facts. So that file you just give to the peer and say translate this, bam, and then you have the whole schema. So the schema is created from your definition file.
So basically I can start programming, making my scheme, my definitions, everything, and then just take this file, send it to the database, and it's ready to go.
Yeah.
That's very neat.
I think it's pretty neat. And that's, again, because it's a closed ecosystem. Then you have control of the whole process from the beginning to the end. So it's you're sure that it's correctly. So you don't have to manually go in and write, and then it's not in sync with stuff. So I think that's pretty cool. Yeah, transaction data. This is pretty cool, because we can say that in what transaction was Fred's name asserted. Then we can say person with some entity number and some attribute name, and then we can call this transaction, which gives us this value here. Because normally the value of the name attribute is Fred. So normally we get values from this column, right? But if we want to get the transaction number, we can write this, which is a special keyword in molecule. So you can get that value, right? I think that's pretty cool, because then that's how you get you remember I wrote the time behind here. So you might wonder, how did I get the time? Because if this is a long number, that's not a time. because that's the reference to the entity that has a transaction instant with the date, so that you get there, right? So that you can get also by writing transaction instant, which is the Datomic's name for a date. So a transaction is one fact. So when you transact something, it transacts the entity, which is the transaction number, and then the time it happened. That's a transaction. So that's how you get to the time. So here comes a really interesting thing, which is like that you can add a transaction metadata, because if a transaction is just an entity that group attributes, then you can define other attributes that you save with that entity. So you have that entity, so you can create some new attributes. For instance, who did it? Like change something, right? So you can make a namespace called audit and user. And then you give it the value Lisa, or maybe the ID number of Lisa, and you associate it with that transaction. So this is a fact, just plain normal fact, but the entity number is just the same number as the transaction number, right? And the way, and we have like, why did they do it? It could be have like a use case, the reference, it was a survey. So you can have a lot of metadata associated with the transaction. So if you save like 100 persons, you have like 2 lines of metadata with the transaction that says who did this operation and why did they do it, what was it part of, whatever information that you want to apply, associate with that transaction. And it's actually very easy to do with the molecule, because you write, if you say, for instance, you say person name is Fred, he likes pizza, then you add this transaction where you can add a molecule within those parentheses. So you see, it's a little bit like the tilde function. So I can add a sub-molecule where I give those 2 facts, which is like the user's Lisa, with the use case survey, and that's those ones. So when you write this molecule, it's going to translate it to this, so it shares the transaction value. So you can go back and see, at that time, what happened, who did it, and what use case was it, or whatever information you want to associate with, what language was it in, who was the actor who initiated that process, or who's responsible, or I mean, whatever audit information you want to have, you can have like 10 different attributes that you could assert a lot in different combinations, and then you can go back. So you this could be like an audit class in your schema definition file, right? I think it's really beautiful that transactions are just total normal entities as your data. So here's some examples of things you could ask. Lisa added Fred as part of survey. You would know that if you write person E5 is Fred. And who is the user and what is the use case? When you write this transaction, it looks up the transaction like an entity lookup, and then look for those facts that share that entity number. What is the value of that attribute audit user? That's this one, right? And the use case is this one, right? And then it gets the Lisa value and the survey, and you get that all there. So this is a way to query the transaction metadata. And I think that's a pretty easy way to do it. Or you could ask, Lisa added Fred as part of survey on Tuesday the blah blah blah. So you get that because you get the time of the transaction and some metadata, which is the user and the use case. So you get both the instant, which is date 1, and you get Lisa and survey, right? So you get when did they do it, who did it, and why did they do it, for instance. Or you could ask more general questions like, who was surveyed? So you could ask for all the person names that are included in a transaction where the use case survey was involved. Right? You see the potential of this? or Lisa's souvenirs like pizza. So you can also add expressions to the transaction data. So, or values that are bigger than that, or stuff like that. So it's as flexible as normal domain data. And then you remember this as of some transaction time. You could say like we have some result, and we have the ID of that person. So the transaction number of that result is we get that from the T, and that's the T here. So we can get this the value of this from this construct in. That's a way to get to the transaction number, you could say. So Datomic saves both the transaction ID and also a sequential number. So that's an extra thing they do behind the scenes. So you have a sequential order of the transaction made. So you can say transaction 1044 and then take the one before, which is like 43. So that's just an extra thing that they have, and that's the T we have here. So at time 2, Fred likes pasta. I don't know why I don't use the as of function. That would be an actual. Yeah, that comes. So first he likes pizza, and then the transaction 2 he likes pasta, right? So we can ask the third ID, which is the entity ID number. He likes something as of transaction 1, which is the time of the first transaction. That would be pizza. And what he likes at transaction time 2 is pasta. That's the way we get access to data at any time. So this T function is a way to get to some data. We could also put in what was the T of that date. So if we wanted to know what did the customer know 1 week ago, or stuff like that. What was the account total at that time, or stuff like that.
Does the ID of an entity has to be long, or is it possible?
It's actually created automatically by Datomic. So it's not something that you put in. So you can create entity IDs. So that's a core function of Datomic.
You would have to have a attribute for your own
Yeah,
ID.
yeah. So if you have a domain ID, if you want to have like sequential argumented ID integers or something, or maybe other kinds of.
Or if you would like convert to this model and you have some IDs in your own data, you would have to.
Yeah. So then you would typically have a column like that you call an attribute that you call ID, for instance. So that would be your domain definition of an ID. And then you have Datomic's own entity ID, which is in the background. You can ask for it, but you can't create it yourself. So that would be typical. Also, if you want to make a composite IDs, if you want to combine an ID number with some text string or something, I mean some SQL database, you can have composed keys. So you could do that manually. And it's the same with the history. You can go back and ask, what did Fred like? And you also want the operation if it was a retract or an assertion. So first, he liked pizza, that was true. But then he didn't like pizza, and then he liked pasta. So you can go in for what comments have a customer had over time, or what has the transaction been on this account, or whatever. So you can have history about it, because nothing is erased.
What would you get if you didn't include history? If you would say Fred likes op.get.
Then you would only get the last two.
So if it's false, the last one?
No, because if you say that that's the last thing that was asserted. So this is the current state of the database.
Yeah, but if the current state of the database is that there's no value.
Yeah, then you will get nothing. You will get an empty list.
Okay. Because the last operation is still.
No, but you have to get the history, wouldn't you?
Yeah, but if you don't have the history, if you just write it without a history, then you just get the current value.
Yeah, which is
and if there's no value.
Yeah, if there's no thing asserted, you don't get anything. Also, if the last one was retracted, you will also get nothing. But you could ask for likes where the operation is false, right? Then you could get the value. What has Fred liked? So the idea is to first likes in the history. So we're only interested in the likes. So that's the pizza and pasta. So now we exclude the operation, right? So we only get the values. And since it's the set semantics, we don't get the pizza twice. Then we get we can see what has he liked over time. And we could ask, where has the person lived over time? What has been bought in this shop over time? I think it's amazing. Or what has Fred disliked? There we come. So where was the operation false? Well, pizza he disliked. Who have disliked not when? Yeah, so it ties to the last the operation ties only to the last attribute. Yeah. Yeah, and here I combine transaction metadata and history. So I ask for the so when was it liked, and what use case and user was involved. Yeah, since it's very much like history. So you just take a subset. When you take from T2, you get from here out. And imagine that was the future, where you give it some transaction data. You saw that in the beginning. So we have some. We want to get the values, the name and ages of some persons, where we imagine some manipulation of some data, and then we want some result. So if we say, what if Fred was updated to become 43 years old, then we give it, that's another command by the end. So instead of just saying update, we say update transaction, and then we get the transaction data back. So that we can put it into this imaging. So we can create arbitrary complex molecules of transaction data. So that's just a way, instead of writing it by hand, you can write a molecule and just add the TH so you get the data back, so you can put it into this imaging stuff. So this transaction data is just a list of quintuplets. So that's just what the topic needs. So yeah, you can see if I update John with the age of 44, then if I save it, if it's a saved transaction, it gets added. If it's an update, then Fred has an updated age. So you have update transaction, save transaction, and insert transaction if you insert multiple data things. So you can insert like a lot of data. So you can, instead of saving one molecule, you can insert a list of tuples of data, right? And then you can get the updated results if you insert. And we can even combine them, because this imaging method takes, it's a var that takes multiple, you can take multiple molecules. So you can have a save transaction, you can have an insert transaction, and an update transaction. Those three comes, they're just separated by commas, right? You give it 3 molecules, and then see what the data is afterwards. And that's what you ask for, if you could give it a lot of data. So you could have like a production system where you would like test a lot of things. If you had those 10 customers, you change this discount and you do this and that, how would the price be of the order total of this for this VIP customer? or whatever. So you could even modularize that. So you make a save John molecule with the save transaction data here, and an insert members molecule here, and then you imagine them in different order to see, does it give the same result if we transact them in different orders. You can see it's very possible to modularize it and combine it in quite complex ways. Do you have some questions for no. I promise it's close to the end now. I know it's a long one. This is not all the. I haven't taken all what's in there, so there are even more things in molecule, and you can see all the tests in the library where I test all the things. So if you download it from GitHub, you can just try and play with it.
So all the boilerplate that you generated using a speaking plugin.
Yeah.
Is the purpose of that to support this dot syntax?
Yeah.
Okay. So if we would sacrifice the privacy a little bit and do person.net and then combinator person.something, then we don't need that. Is that correct? Or then we don't need that boilerplate code generation? If instead of writing like person.name.age,
yeah,
we write like person.name, maybe some combination person.age.
Yeah, of course. Then you would need it because you only have to have one person class, and then you could have all the attributes there. So you could make a DSL that just combines them. You could have the tilde operation just with one attribute things after each other. Of course. But I just thought it would be nice to just, because it also like semantically, the mental model is like, I want the name and age of a person. That's what you say with your words. So what's the most close thing you can write in Scala code?
Especially when you made those pre-made queries in the variable.
Yeah.
And it makes sense to me at least to define I want this.
Yeah.
These 4 things, and I know I always get a list of 4 things with this simple word.
Yeah. And it might only, so you can say like I have an input molecule saying give me all persons of a certain age. And then you write persons of age, make a variable with that molecule. Persons of age 24. And then you get the list. Or it could be much more complex things.
The SPT plugin would generate like person 2 and person 3 for the tuples.
Yeah.
Have you considered using HList instead? Because then you would only need to create like 1.
I haven't considered that. I don't know them really well.
Okay, HList is like.
No, of course. Yeah. You're from Malserving.
Yes, for example.
For example. Yeah, I had an implementation in the beginning.
Yeah.
But it was too slow.
Okay. Yeah.
It was way too slow.
Yeah, because maybe it would be possible to.
It's totally possible. I had it working, everything. But it's just that I had to like 2 parallel systems, both HLists and tuples. Mm-hmm. And I only wanted to use tuples because it was so tedious to write these HLists, and I was sitting with the Scala set library and trying to figure out how shall I do these functional progressions or whatnot. It wasn't intuitive for me at all. So when you're working with here now, then you want some tuples that are typed, and you get the data directly, because you don't need to do any functional transformation, because if you're only interested in the data coming out of the database. So I realized maybe this is not the place to do it, but it would be possible, and it would even be possible to create to apply this whole ecosystem to another kind of database. So you could do it with SQL tables if you wanted to. Some of all the time functions you wouldn't be able to do. That would be really tedious because you would basically have to create all the features of Datomic with the normal SQL database. But all the normal queries, like normal relationships and everything, you could easily do. So you could have an adapter for SQL, an adapter for Mongo, you could have an adapter for whatever, but I'm probably not going to do it. But anyone is welcome to do it. Because then you could use the same simple syntax, type syntax, and just get access to the MongoDB documents or whatever.